Okay, the last type of problem we're going to look at in section 5.4 deals with something called the remainder theorem. Now, the remainder theorem says to evaluate a function's value when x equals some number, so when x equals a, and I'll just make that note there, that a is any value, we can find the remainder when dividing by the factor x minus a. So again, that leads us to example 5. If p of x equals x to the 5th minus 3x to the 4th minus 28x to the 3rd plus 5x plus 20, what is p of negative 4? Now, before knowing this remainder theorem, we would take negative 4 and plug it in for x in each of these places and see what we get. And we could do that and get the same answer as what we would get using the remainder theorem. However, this remainder theorem makes our life a lot easier, especially if you are, say, to not have a calculator on part of the test. Cough, cough, hint, hint. All right. This makes it a lot easier because then you don't have to think about, okay, negative 4 to the 5th power, what on earth is that? Instead, I can use the remainder theorem. So what the remainder theorem says again, I'm trying to find my function's value at p of negative 4. I can find my remainder when dividing by x minus a. And since that is a linear factor, let's use synthetic division. First step, write my coefficients down. I have 1x to the 5th, negative 3x to the 4th, negative 28x to the 3rd. Be careful here because I don't have an x squared term, so I need to put 0 x squared, and then 5x and 20. If I'm really dividing by the factor x plus 4, my negative 4 goes here. Then we do our synthetic division. So bring down our first number. 1 times negative 4 is negative 4. Add down, we get negative 7. Negative 7 times negative 4 is positive 28. Add straight down, we get 0. 0 times negative 4 is 0. Add down. 0 times negative 4 is 0. Add down. 5 times negative 4 is negative 20. Add down, and we get 0. So because my remainder is 0, that also tells me if I were to plug negative 4 in everywhere for x and simplify, I'm going to end up with 0. Okay, so hopefully you see the advantages of using this method, the remainder theorem. We don't actually have to take the time to plug negative 4 in everywhere. We get there without a lot of the stress that we would have otherwise.